Hey y'all, so in this video, I'm going over the Quiz 6 review. So here we're starting with the inequality. So keeping in mind now we have those keywords, phrases like at least, more than, no more than, less than, but also identifying what is the X and what is the Y as you're reading through this. So Brandon is selling bird feeders and bat houses. Now here I'm going to go to the end because I notice that it states that we're going to let X be the bird feeders, and we're going to let Y be the number of bat houses. So here I've got my X's, which are my bird feeder. So I'm here in the first statement. It says that it takes 5 hours to make a bird feeder. So 5 hours to make a bird feeder. So that means if bird feeders are X, then X is going to go with my 5 here. Then here it says that it takes 3 hours to make the bat house, and Y is our bat house. So I have 5X and 3Y. So just from that first statement, I know that I have, oops, sorry about that. I know that I have 5X plus 3Y. So just from process of elimination, I can go ahead and cross out A and B because they have 3X plus 5Y. Now I'm going to keep going. This states here for our other constraints that we have, he wants to have at least one bird feeder. So at least meaning greater than or equal to one bird feeder. And again, bird feeder is your X. So this means that we have X, which is now going to be greater than or equal to 1. Now here, then at least 3 bat houses, and bat was our Y. So Y is at least or greater than or equal to 3. So now we're going to keep going because the last statement states, but doesn't want to spend any more than 30 hours. So think about that. If this person doesn't want to spend any more than 30, then 30 is the most. So he wants to spend 30 or 29, 28, 27. He wants to spend no more than or less than or equal to that 30. So less than or equal to 30, which is why the answer is D. Now, part B is using these same constraints. And we're now going to see which of these coordinates are part of the solution. Now they've already been graphed, but remember, there needs to be shading involved too, right, with our inequality. So option 1 is you could do the shading here by hand, or if you want to be even more accurate, we need to go ahead and shade in our Desmos. So here, I already went ahead and typed them in. So again, here we have our 3 constraints. And notice the graphing does the shading for you in Desmos. So here, if I've got my shading done in Desmos, notice how we're focusing on this triangle section because all 3 sections, all right, so all 3 overlap in this shaded area. So we're going to focus on this region here. So we are focusing on this region here is what represents our solution. So like for example, 3, 2. So is the point 3, 2 in that shaded region? So 3, 2 is right here. Nope, it's just outside of it. 4, 4. Well, that's right here. Nope, outside of it. 3, 3, right here on one of the corners. So technically, yes, it's a solution. Let's check 5, 3. 5, 3 is here, which is not a solution. So remember, your solutions, guys, are all these points that are in this shaded region and including on the line as well. Then if you want to remember, correlate this, what does this 3, 3 mean? Like what was the X and what was the Y? This means, well, X was the bird feeders. So this person can make 3 bird feeders and 3 bat houses. So remember, because this was your X and this was your Y. So again, that's what this means here. So now question number 2. We're identifying the transformations and how we could write this equation for the absolute value. Well, one thing I noticed is that it's flipped, right? Upside down. So if there's a reflection, then to show the reflection over the x-axis, we need that negative on the outside of our absolute value. I also want to make sure that I identify not only the left and right, but what is the slope. So keep that in mind too here. So we have a reflection, so that's going to show we need to make sure to have our negative. Then we went 1 to the left and 2 down. So use the vertex, right? We're going 1 to the left, so 1 left and 2 down. Now let's check our slope. So the slope is, starting with the vertex, here's another point on the line. Well, the slope is 2 over 1. So remember, rise is here, you're up and down over run. So 2 over 1, which makes our slope 2. But remember, right, because it got reflected, that's why it's -2. So here we go. We now can write the equation. We've got our -2 here to show that reflection in our slope here. Then 1 to the left. So that means here, we're not going to put minus, right? Because remember, it's the opposite inside. So I'm going to put x plus 1. But to show 2 down, -2. Then question number 3. We're graphing this piecewise here. So again, first make sure to consider those constraints as well. So keep in mind when we graph, I need an open circle versus our other will need to be a closed-in circle. Both, no matter what, starting at 0. So notice how here I need to graph x plus 3. Well, the y-intercept is 3. So starting here, and then slope is just 1. So up 1, right 1, up 1, right 1, up 1, right 1. Now remember, this is an open circle. So that's why here we need that open and then continuing on greater than. Versus here, we have a y-intercept. Well, that's just 0. So going nowhere. But now our slope is negative. So we're going to go the other direction. Now I could go down 1, but remember, we need to go to the left. So I'm going to continue and go in this direction here with my line, starting with a closed-in point because this is less than, and going here to our less than values. So this is the piecewise. Then of course you can always graph these two in Desmos to check and make sure that you graph these two linear equations correctly. Question number 4. Now going into our spiral review, we're looking to see between these two functions, f of x and g of x, what is the largest solution that makes this statement true? So given these two equations, what is the solution to this system? So remember, guys, if you need to, graph each function in Desmos. And so remember too, when we're looking for the solutions after graphing these two functions in Desmos, so here I've got my f of x and here I've got my g of x. So graphing these two looks like this. Now, keep in mind too, see how I'm kind of like starting off small? Always zoom in, zoom out if you need to, guys, to look at the graph entirely or the graphs. So I'm going to go ahead and zoom out because now notice technically how many solutions do these two equations have? Well, they have two solutions. We have a solution here and here. So remember, the solutions are where the two graphs are crossing each other. There is no need for you to identify any other points, right? If we're talking about the solution, we just need to know where they're crossing and we need to know the largest. So remember, the solution is always the x coordinate. So here looking at the larger of the two x coordinates, that's why the answer is 1.8 and the answer here is D. So now in question number 5, we're finding the inverse of our function. So make sure, right, we need to switch our x and y. X is equal to 3 times 2 to the y plus 1 minus 1. Now keep in mind, We have an exponential. So in the end, guys, our answer should be a log. Before we do that, remember, right, we have to get the exponential by itself. Now we have two things going on, so treat it like a two-step. We always add or subtract first. We're going to go ahead and do the opposite and add 1 to both sides. So x plus 1 is now equal to 3 times 2 to the y plus 1. Now this exponential, though, is still being multiplied by 3. So do the opposite, which is divide by 3. Now we've got this wonky fraction, but leave it, right? And equal to our exponential. Now the exponential is by itself. Now you can write it as the inverse, which is the log. Well, what is the base? The base, remember, guys, is always what's raised to the exponent. So the base is 2. Log base 2 of what? X plus 1 divided by 3. And close off the parentheses, right? Keep that all together. Equal to your exponent, which is y plus 1. However, we're still having to solve for y, so now make sure you subtract 1. So that's why the inverse is our log base 2 with our fraction here, x plus 1 divided by 3, but then outside of the parentheses, minus 1. So now in question number 6, we're solving for x. Now, common mistake is people want to divide by 4. Don't do that, right? Because 4 is a base being raised to a power. So here to solve, inverse. Well, what's the inverse of an exponential? A log. So we need to write this as a log. So again, what's the base? Well, the base is 4. Log base 4 of 12, which is equal to x plus 5. Now, how do we evaluate this log here? Change of base. So this is when we divide now our two logs. So what's going to go up top? Log 12, right? Because remember, the base always goes in the bottom. When you divide here, these two values, you get approximately 1.79. Now that is equal to x plus 5. So now the last step here to solving for x, if we're adding 5, subtract 5 now from both sides. And x is going to be approximately negative 3.2. So now question 7, there's actually two parts to this. So 7 part A and 7 part B. Now before we get started, there was a little typo here. Sorry about that, guys. So the answer was actually not here. So I'm just going to go ahead and cross these out for part A. But now remember, we're using the initial investment. So this is our P here, what we're starting with, $2,000. And we have this investment after 8 years. So that's our time. Now, if it's compounded weekly, so notice how we're compounding weekly, which means this is a value for n, which weekly is 52 because there's 52 weeks in the year. At our rate of 4.5% or 0.045, right? Move the decimal 2 times or divide by 100. So now if you recall, remember, A is always equal to, this is P times 1 plus. Now we have the fraction, right? Because of our n value. So it's not just 1 plus R, R divided by n. Then remember, it's not just raised to the t power now, right? Because of this n value, multiply by n as well. So here we go. A is equal to P, which is 2,000 times 1 plus our rate, 0.045 divided by n, which is 52, all raised to the t power, which is 8. But don't forget to multiply that by 52. So like this exponent here, if I'm not mistaken, is 416. So now put all this in the calculator and you should get that this is approximately $2,866.21. Now part B, we're using the same initial and time. But this says compound continuously. So now remember, when we had continuously, there was no value for n because now we use E. So this was our PERT formula, P times E raised to the R times T power. Now the rate did change to 0.032. So again, here we go. A is equal to Our initial was 2,000, but now times e being raised to the rate, which is 0.032 times t power, which is 8. Then put that in the calculator, and the final amount is approximately $2,583.51. So now question number 8. This is going back to solving our log equation, but notice we have multiple logs, right? We have log base 2, log base 2, and they're being added. So what was the property? Well, what addition meant multiplication. So we are still keeping that log base 2, but to condense, we're going to multiply 3 to 5x plus 6. So this is 3 times 5x plus 6 and distribute. So really we have log base 2 of 15x plus 18. That is what's equal to 8. Now remember, we're still using inverse, right? Well, if this is a log, the inverse now is an exponential. So what is the base? 2. So base 2 being raised to the 8th power, which is equal to 15x plus 18. Now we can go through and solve. Well, here, 2 to the 8th power is 256. Sorry about that, guys. My pen's a little wonky here. So here we've got 200, sorry about that. 256 is equal to 15x plus 18. Now we can just go through now and solve our two-step, subtracting 18 from both sides. So now here I've got, sorry, I'm running out of space, so I'll just write it over here. Now you should have 238 is equal to 15x and divide now by 15. So that's why here you should get that x is approximately 15.9. And so now here, let's solve our log equation. Here, we're solving for t, so instead of x, now it's just t. However, the log is not by itself. See how it's being multiplied by 1/2? So we need to divide by 1/2. So you could divide by 1/2 or multiply by the reciprocal. I'll just go ahead and divide by 1/2 since it's being multiplied. So dividing by 1/2, here you end up with log, and then t minus 3 is now equal to 8. Now we can solve this and again convert it to an exponential. But remember, when no base is given, what's understood to be here? Base 10. So this is 10 being raised to the 8th power, which is equal to t minus 3. So really you've got 10 to the 8th, which I believe is like 100 in million, plus 3. So like 100 million and 3 is what's equal to t. So now here in question number 10, we're solving for m, but we do have multiple variables, so keep that in mind. We also here solving for m, which is in our exponent, but notice how our exponential is not by itself. Notice how it's being multiplied by 1/3. So again, I'll just go through here. We can divide by 1/3. Now you of course can multiply by the reciprocal, but I'll just still continue on and go through with that process. So if I'm multiplying by 1/3, divide by 1/3. So now here, 5 divided by 1/3 is 15. So 15p is equal to 2 to the mn power. Now the exponential is by itself. So again, the inverse is now a log. So here I've got log. What's my base? Well, base 2 here, right? Because that's what's being raised to the exponent. Log base 2 of 15p. And again, close that off, is equal to mn. So now here we can solve for m. It's being multiplied by n, so now you need to divide by n. And that is our equal to m. So now in 11, we're condensing. Now think about it. Going back to question number 8, we condensed here. Whenever you have more than one log, using your property. So when adding, you multiply. So when subtracting, you divide. Another property is when we had the coefficient, we raise that to an exponent. So this is actually x squared. So like 3 here is also an exponent. So now this is minus log, but y cubed. No coefficient, so we're good. Now we can write this as 1 log. Now I notice subtraction, which I remember that subtraction means division. So I'm going to go ahead and set this up. And here, see how x squared is positive, so x squared needs to go up top. But y cubed is being subtracted, so that needs to go in the bottom. And xy is also being subtracted, so this also needs to go in the bottom as well. Now we can start simplifying. Well, one thing I notice here is I've got 2 x's up top, but only 1 x here. So 2, but taking away that 1. So now I'm left with 1 x. So I still have the x up top. Then here we have 3 y's and another y. So now we actually down here have not 3 y's, but 4 y's. So y to the 4th. Now question number 12. This is going back to our graph and identifying which of the statements is true. But remember, if you need to know what exactly is happening here or how it looks, we need to then graph this in Desmos. So now make sure to graph this in Desmos. And guys, remember to graph that. You need to make sure to use parentheses to keep that exponent all together up top, the x plus 3. Otherwise, the plus 3 comes down. So remember to use parentheses. So this is what our graph looks like, all right? So now let's go back to A. As x approaches infinity, what is our f of x approaching? Well, as we're going to the right towards infinity, what is our graph doing? Well, it's going down to negative infinity. So this statement is false because this should say negative. Now let's go to B. We're increasing on our interval here. So let's take a look. Reading it left to right, what's happening? Well, our graph is decreasing, not increasing. So that statement is also false. Now let's look at C. It says our graph f of x is all positive from negative infinity to infinity. So the entire graph it's saying is positive. So let's look. Going back, well, notice, guys, our entire graph is below, which is in the negative. So here, let's check then that D is our true statement. The range is negative infinity to negative 1, which is saying that these values are less than negative 1. So negative 1 is our highest value, which that is the case here at negative 1, and it's below. So that's why here the answer is D. And so again, remember too, guys, right? For an exponential, it's the domain that is all real. So that also matches too that the range is what is cut off here because the domain is all reals for your exponential. Now 13 and 14 are review on our exponents. So remember here, guys, this is needing to rewrite because notice how we have different indexes of 4 and 3. So still keep it straight up, x to the 12th, right? So that's x to the 12th. But this 12, x to the 12th, is technically over the index, which is 4. So this still here in the denominator, right? That is just straight up x to the 9th. But because of the index, it's x to the 9th, then over 3. Now here we can simplify, right? Because what is 12 divided by 4? 3. And then what is 9 divided by 3? 3. Well, what is 3 divided by 3? 0. So really, x to the 3rd divided by x to the 3rd is just 1. So that's why here the answer was A. So now question 14. This is now, remember, right, when dividing, we subtract the exponents, and again, top to bottom, subtract them, but the bases have to be the same. So like for my base x here, I'm going to take negative 3, and I'm going to subtract which exponent? The 2/5. because the bases have to be the same. So now you can put that right up in the calculator, right? -3 minus 2/5, and you should get -17/5. So that is the new exponent for x. Then you can do the same thing for y. Y has an exponent of 5. So 5 minus which exponent? The 1/4, because again, the bases are the same. So 5 minus 1/4 is 19/4. That is the new exponent for y. However, is this our answer? No, because remember, right, we can't leave a negative exponent like we have here for x. So that means keep y up top, y to the 19/4 over x to the 17/5. So now last question number 15, going back to our graph. But which statement is false about our log? So again, we need to make sure, guys, to graph this in Desmos so that we can see here how this looks as we go through. So if you graphed it, this is how it should look. So remember your log, you have the vertical asymptote, right? Which is here at -3, constantly going up and constantly going down. So the range now is all reals because this is constantly going up and down. So keep that in mind. Here we go. For our end behavior, as x approaches -3, which that's what we just said was the asymptote. So as x approaches -3, what is our end doing? It's going down to -infinity. So this statement is true. Let's go to B. Oh, the domain. Is the domain all reals? No, because of the log. Remember, guys, it's the range that is all reals. The domain is cut off because it's going all the way up to -3. So B is our false statement. Now, to show why the others are false or true. So we are increasing, yep, starting at the x value, -3, and going on to infinity. So that's why C is true. And this says f of x is negative from this interval. So from 5 to 10, so let's locate those x values, right? So from 5 to 10, yes, this portion of the graph is below the x-axis in the negative. So this statement was also true. So B was the false statement.